Okay, we're looking at our second video on general logarithms and solving log equations. We're going to look at, in particular, two examples to illustrate what we've seen before. And indeed, in the first one, we've got log of 3x minus 2, and that's to base 5 equals 2. And there are perhaps two ways of doing this, so I'm going to put one method up here, and one method is just to turn it into basically index form, and so that would be 5 to the power 2 equals 3x minus 2, so it's just conversion. So we have 25 equals 3x minus 2. We have 27 equals 3x, and 3 times 9 is 27. Other way of doing it is crafty. We've got rewriting the left hand side. How can we write the right hand side as a log to base 5? Well, because we know 5 squared is 25, we can use that information. Log to base 5 of 25 is 2. So we can do some rearranging now. Because both sides are taken to log of base 5, we can equate both sides, equate the logs of both sides, and on the left we've got 3x minus 2, and on the right we've got 25. And can you see that we've got the same equation to solve as we had over there? 3x minus 2 equals 25, so we get the same answer. So two ways legitimately of doing the same thing. In the second example it looks more difficult, so you can see up the top of the screen there we've got log of 2x minus 1 to base 10 plus log of x minus 1 to base 10 plus log of 3x minus 3 to base 10. I'm going to apply to the left hand side log law 1. So we've got a sum, we can turn that into the log of a product. So we have 2x minus 1, x minus 1 as a product, and on the right hand side we make no changes. Whoops, try again, 3x minus 3, and we look at equating each of the sides like we did in the previous example, and that will take us forward towards the answer. So they're both to log of base 10. Sorry, it should be a 1. We fix that up. Fixed up with these two sides of the equation equated. So on the left hand side we can use the distributive rule, multiply out, and or FOIL if you prefer. So we've got 2x squared minus 2x minus x, which is minus 3x, plus 1 equals 3x minus 3, and we can subtract 3x minus 3 from the right hand side and the left hand side, so we have 2x squared minus 6x and minus 2 equals 0, or in other words x squared minus 3x minus 1 equals 0. We can solve that quadratic. Oh, sorry, I've just noticed a little error that I've just need to erase there. Back on this line here we've got, sorry, I should have added 3 onto the plus 1, which makes that plus 4, and then we divide everything by 2 and we get a plus 2 there. My apologies. We get x equals 1 or x equals 2 as our answers for x. Now, this is where you need to be thinking. Look at the logarithm we've been given and look at one of the answers, the first of the two answers, when x equals 1, and look at that, or more importantly, look at that. Now that is, when x equals 1, this becomes undefined because we have log of 1 minus 1 to base 10, which is log of 0 to base 10. Now if x equals log of 0 to base 10, we've got a bit of a problem, because what that's saying is 10 to the x equals 0. Now have a think about that. Are there any solutions? There are not any solutions, and another way of looking at that, if we've got 0 entered in on a calculator, if we hit the common log or just log to base 10, it's invalid. So that's not a valid answer. So we scroll down to our answer and we look at the reasonableness of our results. There's a criteria for you, and basically that one's out. So x equals 2 is the only valid answer for the reasons I stated above. It'd be nice if you actually had those reasons as briefly as part of your working. Oops, only valid solution. Try some.